Yeah, welcome to the jungle and welcome to EclipseCon Community Day. This is, let's start with I can't switch. Magic. Clicker doesn't work anymore. Try again. Oh, now it works. Yeah, my name is Gerrit Grunwald. I'm working for Azul. We do JVMs. I'm also leading the Java user group in Münster, so if anybody's interested in speaking there, just let me know. Apart from that, that should be it. You can follow me on Twitter, or name it X, whatever you like. It's hansolo_, and this is the only way you can reach me, really. I will respond to all these. If you ping me there, I will try to answer you there. All right. It worked before. No, can we next slide, please? Or can we try something that I don't have to tell every time next slide? Just give me a second. Tat's eben, aber jetzt gerade nicht mehr. Muss er vielleicht nochmal einmal sich verbinden? Yeah, we're in Germany. Forgot about that. Danke. Okay, so if you would like to have the slides, I uploaded them there, and they're only there for 60 days, because this, I don't know why, but I used SlideShare, and that sucks. So if you would like to have them, otherwise just ping me, I will send it to you, no problem. And I think maybe they will also be collected after the conference. Again, next slide, please. Done. Okay, OpenJDK. So we need some more time here. First of all, who has OpenJDK installed on his machine? Are you sure? What you have installed is a build of OpenJDK, and that's a distribution, and that's a difference, right? So, and this is the main purpose of this whole session, because people just say, oh, I have OpenJDK, without knowing what it is, most of the times. So it's a free and open source implementation of the Java standard, platform standard edition, or Java SE. And it has a website that you can find here, right? openjdk.org. And because it's an open source project, you can also get the source code. In the meantime, since JDK 16, it's available on GitHub. Before that, it was Mercurial. So if you would like to check it out, you can check it out there. But be aware, it's quite a lot of code, and it's not so easy. And you can also contribute, but be aware too that this is not easy to become a contributor there. Okay, contributors. So this is really not the way I do it usually. Come on. Okay, so these are all the contributors. And as you can see, it's not one company, right? It's a lot of companies. And you see in the middle, there's many individuals. And this means there are a lot of one-person contributions to OpenJDK. And I can't name them all, but you see there are big companies like Amazon, whatever, Google, Microsoft, they all support OpenJDK and contribute to it. And that's good because it's not a one-man show. And you don't want to rely on one company, right? So this is a good thing with Java in general and OpenJDK in this case. And it has a roadmap, of course, because it's a big project. And who knows Java 6? Who worked with Java 6 in the room? Yeah, probably the one with the gray hair. I just hide it, right? That's a smart move. We see from 6 to 7, it took 4.5 years. And then from 7 to 8, it was 3 more years, right? And that is a problem because we had to wait multiple years before we can really test something new. Why is that a problem? Because before you can do something in production, you have to wait for 3 years, then you get the new version, then you start testing it, and then it might take up to another year until you really run it in production, right? So this is the problem with this old cadence, and they changed it to this one. So that's the new release cadence, and we see we have every 6 months we have a new release. And it's way better, because now you can test new JDK versions every 6 months, especially new features like Loom, JDK 19. Before it was then an LTS version, and we will come to that in 21. So that's way better. And we have, I go through these things even if you know them. because I have a reason for that. We know this is the Java development kit, and there is development in the name, right? So there's a reason for that. And who's using a JDK in production here? For any specific reason? There are reasons to run a JDK in production, probably most of the times for debugging reasons, but usually you shouldn't do that. So therefore you should use a JRE, which is a Java runtime environment. And the difference is that the JRE only contains the virtual machine and the class libraries, where the JDK also, in addition, contains the Java C compiler, debugger, Javadoc, and all these things that you don't need to run it. Why is that important? Because the JDK is way bigger, right? So if you run it on a node somewhere in the cloud, then you would like to have it very small, so use a JRE. The recommendation is up to JDK 8, you should use JDK in development, JRE in production, but from JDK 9 onwards, you should use JLink. Who knows JLink? Who used JLink? Oh yeah, that's what I always see. That's the main reason why I put JDK JRE in here. So JLink is a tool to create a custom Java runtime environment for your application. That means there is another tool called JDEPS, and you can run JDEPS against your application, and then it will give you a list of all the stuff that you need from the JDK. And then you can create a Java runtime image just for your application. And the good thing about that is that's first of all smaller than a JRE, and it doesn't contain stuff that you don't need. And that means it could be even less vulnerable for CVEs, for example, because stuff that is not in your runtime environment can't be hacked, right? So you have to think about it using JLink. At least take a look at it and check it out. It's worth it. Then we come to distributions, and you might be surprised how many we have. We have builds of OpenJDK, and these are all the different builds that are available. It's around 20. And you see there are some dead ones, like Adapt OpenJDK that died with 1602, and then there is OJDK build, which is the community version of the Red Hat JDK, and that died with 1702 or 1703. The reason is probably that they also seem to switch to Tamarin. And there's Tamarin, which is from the Eclipse Foundation. Who's using Tamarin here in the room? I would like to see all your fingers, right? Tamarin is not Adapt OpenJDK. Even if the Adopt OpenJDK guys claim it's the same, it's not. And they did a smart move by going to the Adopt OpenJDK page, and the last download you get from 17, it linked to Tamarin. And it's not really, it's a different distribution, right? So it wasn't really, I wouldn't say fair, but it's not really good to do that in my opinion. But it doesn't matter. We see we have a lot of different distributions here. Like I said, it's around 20, and that's not all, because there's also builds of GraalVM. Is someone using GraalVM here in production? Nobody? It's not only GraalVM. We have Glue on GraalVM. We have GraalVM Community, which was formerly known as GraalVM CE, and now it's just GraalVM, which was GraalVM Enterprise. They recently changed the naming. And then there's Liberica Native Image Kit, that's from Bellsoft, and Mandrel, which is a build of GraalVM from Red Hat. So we see also there we have different versions of GraalVM that you can use. So the question is which one to choose, right? What is the JDK you should choose? And you can say, oh, I don't care, right? Or you can just say, oh, someone told me I should use that one. But we should find some differences between them. Because even if they build all on the same source code, there are differences. And I tried to figure out some points like term of support, updates, compliance, cost, performance, and features. So we will look shortly in all of these things, and I will explain it to you, and then you might understand why it's worth to take a look at it. So term of support, what does it mean? Who knows STS, short-term support? Yeah, it's not very well known. And then there is LTS, where Oracle claims there is no LTS version, right? That's true in some way, but we will come to that in a second. That's long-term support. So, okay. As we can see, this is from JDK 9 to 21, all the different versions, and all the white boxes, it's STS releases, right? That means short-term support versions. And they only have support for 6 months. That means, let's say you go to JDK 12, and in JDK 12 came a new feature, JPackage, which is for building native installers and executables with Java. And let's say you would like to use that because you need it. So you switch to JDK 12, even in production, because you would like to use the feature. Then you get updates 12.01, 12.02, and that's it. And then suddenly JDK 13 came out. Oh, would you like to switch to JDK 13? Because that also comes with new features. You don't need them, really. So you stay to JDK 12. Okay, that means you don't get any security patches anymore. You stick to 12.02. And then you have to wait. You have to wait until JDK 17 because that's the next long-term support version, right? That gets supported longer, and support means you get security fixes. And if you can, okay, this is terrible. One more time. Go. Damn it. So, yeah, as you can see, JDK 11 was a long-term support version, and then we have 17 and 21. Oracle now claims there is nothing like an LTS release, and this is in some way true. There's not really a definition, a hard one. But Oracle, for example, gives for these releases long-term support, and all other vendors do the same. So there is, in general, there is something like a long-term support version. And the next one was 21, which came out a couple of weeks ago. So that means if you stick to 12, then you have to wait until 17 comes out before you get really long-term security patches for your version. And that's problematic. So that means you should really, in production, stick to LTS versions, and then in development, you can use, of course, all the short-term support versions, right? So just to make that clear, because it's still, you see, I think it's still 150 days until the next JDK will come out. So it's not around the corner. And I have another session about security where you see all the different CVEs that's piling up, even in the JDK. The JDK is vulnerable, right? And if you stick to one of these versions, for example, if you stick to JDK 11.0 and you don't do any updates, security patches, then you pile up to 17 CVEs in the meantime that are in the JDK. So you also should really keep your JDK up to date, always with the latest updates. All right, yeah, question.
Do you know why the 11 is supported longer than 17? Because one would expect that 17 would be supported longer.
Oh, you will be surprised that 8 is even longer supported than 17 and 21. This is probably because of the usage. People stick to 8. Who's using 8 here in production? See, it's not a problem, right? But this is the reason why they extend that from time to time. And let's say when the long-term support for 17 will come to an end, and Oracle see, oh, there's still a lot of companies using it, they will extend it. This is how it works usually. So that's the reason why we have different dates, and they always change that over time. So this is not true anymore, right? 17, I think, is in the meantime even, I'm not sure, but 8 is now till 2032 also. Okay, so that means STS releases only for 6 months, and LTS releases for years. So you should really stick to LTS releases in production. And the other thing is not every distribution gives you an STS release, right? So if you, for example, if someone is running on Azure here, Microsoft, then you probably should use Microsoft JDK. They only support 11, 17, 21. They don't have 12, 13, 14, and so on. So that means if you then would like to develop for new features, you need a different distribution in development than you use in production, right? So all these things, you have to keep that in mind. Because other distributions deliver all the different updates, but not everyone. So that means recommendation, of course, in development, whatever you like, but in production, stick to LTS releases, because then you can make sure that you get security patches, and that's the important part. Updates, that's the next thing, because this is also something that's not known by many people. Who knows critical patch updates? CPUs, okay, one. And who knows patch set updates? PSUs, the same person, okay. That's what I thought. So we have CPU. They only fix vulnerabilities and really critical issues, and that's it, nothing more. Then we have PSUs. The PSU contains the CPU, plus it also has, if the clicker works, come on. Oh, no, it was, okay. So it has non-critical issue fixes and new features, not new features like Loom, it's small features that they implement, right? So they do that, test it, and implement it. These new stuff can introduce problems and issues, right? I have an example at the end of this topic. And how it works is, we get these updates 4 times a year. Tomorrow is the next one. Tomorrow is the next update. And it's always on a Tuesday, and I think it's the 3rd Tuesday every 6 months. And it starts in January. And when we take a look at, for example, 1701 came out in January. And then we see on top is the PSU, and the bottom is the CPU update. And you see the PSU contains the CPU, right, on top. So what happens, the next update we get is in April, and then the PSU contains the fixes, right, and new features. And the CPU that comes out only, and that's the difference, it takes the 1701 and just fixes all issues that happened in 3 months. That's what it does. It only contains security fixes from that one. Yes?
Do you really have got the same version number?
Yep.
For CPU and
Yes, it is the same number, even if they are feature-wise 1 step behind. Yeah. The problem is you won't get CPU updates somewhere for free. You have to pay for it. That's the reason why nobody knows that. That's the reason why some people or companies pay for support for Java, because then you get these specific updates. And yeah, then it goes on with the next one. In July, again, the 1703 introduces fixes and features like really small features, right? And then the CPU, it gets just the fixes for 1702, right? This is how it works. And you can imagine that companies who does that, they have to spend more time, money, and people to create these things, because they have run another batch of creating builds of OpenJDK that just contain these fixes, right? This is one of the reasons why you have to pay for it. Okay, and then the same for October, and that is how it works. Nice. Go. Okay, CPU updates are 3 months behind PSU updates, but way more secure, right? Yes, one question. It is for every LTS version, exactly. So, yeah, okay. What on the slide before, it said that PSU updates are available from all the vendors. So everything that you download from websites, this is PSU updates. CPU updates are only available from Azure, Bellsoft, and Oracle. No other companies do that. And that's the reason if you go to the website from Bellsoft, they just say, we also give you CPU updates, but they don't give it to you for free. You have to sign up and you have to pay for it. And for example, some distributions make a smart move by saying, oh, this update contains all the fixes from the CPU. Yes, of course, because the PSU always contains the CPU, right? But it is not a CPU. CPU updates, like I said, you have to pay for that. And some people might remember in the JDK 8 days of Oracle's JDK, you find on the website something like 8U 251 and 252. That have been the 2 different versions. People have been confused, what is the difference, right? Because they didn't really explain that. And that was the difference. So recommendation in development doesn't matter. Production, if you run mission-critical stuff, you probably should run a CPU. At least think about it. And one example that I have, why it makes sense, there it is. One example was with PSU 8.252, there was something introduced that prevent Hadoop cluster and Solr from running. So it means if you switch to that one, suddenly that stopped working. And that was one of these features that introduced a new issue. If you, on the other side, would use a CPU 851, because that only contained the fixes from 242, right? The one before, that worked. This is the reason why there are CPU updates, and we have many of these examples. So it's not that rare that this stuff happens, just that you know. Okay. Compliance. Yeah? TCK. Who knows what the TCK is? Okay, a couple of people. So it's the Technology Compatibility Kit. It's licensed by Oracle. Oh man, it's terrible. So what is it? Yeah, it was originally developed by Sun. In the meantime, it's intellectual property and licensed by Oracle. It contains, for example, for JDK 11, more than 120,000 tests. And this is not testing stuff like applications. This is testing the JDK implementation, the Java spec implementation. So that means if you use Loom, somehow someone has to make sure that it works the way they say it works on all the different platforms. And these tests are made for that. And they are defined in the so-called JCK. And the reason why I mention both of them is the JCK is part of the TCK. The JCK is actually that these are the tests. And some companies, I think Alibaba, for example, they claim on their website they are compliant to the JCK. That's why I mentioned that here. It's the Java compatibility kit. And, okay, how to access the JCK. So it's available for free in general. So you can go to Oracle and say, I would like to have the JCK. And then you must meet the terms of the OCTLA, which is the OpenJDK Community TCK License Agreement. What a nice acronym. And this means paperwork, right? You have to do that, but in general, that's for free. And you must sign the OCA, Oracle Contributor Agreement. Once you do that, you can apply for the TCK. And these are the distributions for JDK 8 that are compliant to JDK. You see, it's not the 20 anymore, right? Because not all the distributions are TCK compliant. What does it mean? It means they don't comply to the Java SE spec. It means there could be code that breaks when you use one of these distributions. With these ones, you can make sure that you can exchange them. That's guaranteed by the TCK, right? That's the idea behind it. This is for JDK 8, and you see stuff like Bisheng and Dragonwell. Who knows Bisheng? Nobody? Yeah, probably not. This is from Huawei. This is huge in China, but not here, right? We use stuff like Tamarin or Zulu or whatever, but they use Bisheng, Dragonwell, and Kona. That are different distributions. Then if we go to JDK 9 and above, you don't see Bisheng, and you don't see Dragonwell here. And the reason why I mentioned that is just because the company claims on its website we are compliant to the TCK doesn't mean all the distributions from them are really compliant to the TCK. And that means you use Dragonwell, you see on the website, oh great, it's TCK compliant. Then you update to the next version, 17.11 or whatever, and then it's not anymore. And that's why we at Azure, for every package that we give you, you can also get a PDF certificate where we tell you and guarantee this is tested and TCK compliant. Because it's not enough just to say we are TCK compliant, because this is not really guaranteed. It's a thing of trust in this case. But you see that it's not here. That means they have some stuff in there that breaks code, right? And when I talk about it, then it means the JCK stuff, for example. I hope I have it on the next slides. I guess so. If we can see it. Oh, come on. Can you switch to the next slide? Ah, okay. Yeah, I missed it. So it is just to mention that if you would like to run the JCK tests on your machine, you can do that. And then you can go on vacation. And then you come back a week later, and then it might be finished, because this stuff it takes a long time. You need a CD-ROM, you need a printer, a sound card. In principle, everything that Java can address needs to be connected to your machine to run the tests, because they have to make sure that everything works, right, on all the platforms. Now you might get an idea what it means for vendors like Eclipse Foundation when they create these packages, the distributions. It takes a long time to run through all this stuff to make sure it really works on all the machines, right? It's not something that you can just do on a weekend. It takes sometimes weeks to do that, at least days. Okay, then there's another test suite, which is the Aquavit, Adoptium Quality Assurance Vitality and Speed Test Suite. And that came out with the Adoptium project, right? And okay, so what is it? It ensures that all additional qualities are present that make it suitable for production use. First of all, you need to have the TCK to get the Aquavit, to be able to be compliant to Aquavit. And this is not for testing the Java implementation, but this makes sure that, if I can switch, yes, it collects a collection over 350,000 tests. And it's more testing the applications in real-world utilization patterns. So that means instead of testing Java itself, this one tests how good performs the distribution in real-world scenarios, right? To make sure in not only performance-wise, but also security and durability tests. So it's a lot of stuff that's going on there. And if we take a look at the distributions that are compliant, then this is just these 5 that are compliant for JDK 8, for Aquavit compliant, right? You will find them on the Adoptio marketplace page. And as you can see, Bisheng and Dragonwell are on here because they pass the TCK, so that they can also do the Aquavit test. But for JDK 9 and above, or 11 in this case, we don't have Dragonwell and Bisheng here. Right. And if you go to the marketplace, you won't find them. If you select Dragonwell 11, there is nothing for Aquavit certified JDKs. Okay, these are the 5 that are also complying to Aquavit. Okay, so recommendation in development, whatever you like. Production, you really make sure it's a TCK compliant distribution. You never know. If you have to switch to another one in the future, then you really would like to make sure it works. You don't want to have stuff breaking just because of the JDK implementation that was used, or the distribution. Cost. Yeah, cost is also something that is a little bit of a problem in our community because we are used to get everything for free, right? You just think, hey man, someone builds this stuff for me, I just use it. It's easy, right? Tamarin is for free, of course. Someone has to pay for all that stuff, right? So the Adoptium and Eclipse Foundation, they are happy to have sponsors. They do all this stuff. But other companies somehow have to pay people and hardware to do it, right? So, but that's the way it is. And for that reason, if I can switch, oh, too fast, go back. No, yes. These are all the free distributions that you can get. That means most of them. You can get them for free. Free means free in production. You see there's an asterisk, and this is not only, I also put the GraalVM stuff here. There's a GraalVM and Oracle JDK has this asterisk there, right? Because it is free in Oracle terms for 3 years. After that, it goes back to the so-called OTN license. And the OTN license, they changed the pricing for that in January, now is based not on vCores, but it's based on number of employees. Let's say you are Mercedes-Benz. You have, I don't know how many employees. That's nice. You have maybe 1,000 developers, you have whatever, 10,000 cores. You probably have more employees. Then you pay for the number of employees. But that's not enough. Because they decided, wait a minute, if they have third-party people, vendors that deliver them stuff, they also need to pay for them. Oh, Bosch is delivering something to Mercedes-Benz. Oh, Bosch is also big, so they pay also for them. So, of course, they say, yeah, it's free. You can use it for 3 years. And then you have to switch to the next JDK. You have to. Otherwise, you fall back to that license. You are not in a danger if you're a small company. They aim for the big ones. But you have to be aware. And the problem why I mentioned that here is if you, for example, use Oracle JDK 17, right, that came out 2 years ago, then next year in October, this will fall back to OTN license. So just keep that in mind. That means from next year, October, you will be could be charged by Oracle if you use Oracle JDK 17. The same goes for GraalVM. It's the same thing. It's a Java SE subscription from Oracle. They cover both. Okay. Paid versions. Yeah, we also have paid ones. That's one of ours. It's the Platform Prime. I will come to that. This is based on number of cores. IBM Samaru certified. You have to pay for that. Again, this is not because IBM would like to charge you for something. This is because Oracle decided, oh, you know what? Your OpenJ9 JVM implementation is not really OpenJDK, so you have to pay for the TCK. Usually it's free, but not for IBM. So if they would like to have the TCK, they have to pay for it. And that's the reason why you have to pay for the Samaru certified version here. So again, a nice move from Oracle. GraalVM, I already mentioned that, and Oracle JDK, they are free for a couple of times, and then suddenly they switch back to the OTN license. Okay. performance. Oh, that might be interesting. Who's interested in performance and JDKs? Yes, that's your topic. We have a baseline performance. What a surprise. It's more or less the same for all of them. There's not really a big difference. There are some differences. And when I see GraalVM, I don't mean the native image stuff, which is slower than JDK. Just the startup time is faster, right? So, but the performance is not as good, and there's a reason for that. But if it's based on OpenJDK source code, you wouldn't expect that it's faster because another company builds it, right? So this is more or less all the same. There are differences, especially with the Samaroo stuff from IBM. This could be different because this is a different JDK implementation. But in principle, if you really take a look at performance, these are more or less the same, no big difference. But if you really need, I said that already. If you really need more performance, then we have to take a look at the JVM itself. And the JVM has different parts like the class loader subsystem, JVM memory, and execution engine. And I don't go through all this stuff because the clicking is so nice. I just click through it and you can read it. The most important part is the execution engine. Oh. Yeah, go. Sorry for that. Go on. Oh, yes, there we go. So we have the execution engine, and you see we have stuff in there like the interpreter, the JIT compilers, profiler, garbage collectors, and other stuff. You can change stuff in the execution engine without breaking the TCK, right? So what you can change the JIT compilers, and you can change the garbage collectors. And that can lead to different performance, right? So what we did for Prime, we just exchanged the compiler, the C2 compiler, with our own compiler that we wrote, which is based on LLVM. And we also implemented our own garbage collector. And who knows the ZGC, which is now in JDK 21, garbage collector? Nice. If you read the spec of ZGC, and you read the paper that our CTO published 12 years ago about C4, which is our garbage collector, you will figure out this is the same. So they read the paper and implemented on their own. So ZGC is more or less the same that C4 is in Prime. And Oracle, oh, okay, nice. I have to go back. That was way too fast. We are now slides ahead. What happened? What's going on? Okay, here we go. GraalVM. This also has a different compiler. So what they did, because there's a C2 compiler, which is from Suntimes, which is written C++, and that's quite complex code, hard to maintain. So they decided with the GraalVM labs, the Oracle Labs team decided years back, that it would be a good idea to re-implement the C2 compiler in Java itself, right? And then they used the native, or let's say the AOT compiler to create a native image from the Graal C2 compiler, and then use that as the OpenJDK compiler. That's what they do. And then for that reason, and this is GraalVM former enterprise. This is faster. They do better optimizations. This is also the one you have to pay for after 3 years. If you use the community edition, that's free, but it's way slower. Just keep that in mind. People are always like, oh, native image, so great, startup time, 30 milliseconds. Do a comparison on the performance to a JIT. Quarkus, they have a test, it's 50% slower sometimes. Yes, you gain startup performance, but you lose performance at runtime. So you have to keep that in mind if you work with native images. Oh, that leads me to features. I hope we're still on time, yes. There's Amazon Corretto. Who's using AWS and Corretto here? Lambdas? Nobody, okay. So what they did, they implemented Snapstart, which is based on the Crack API that we came out with last year, and they call it Firecracker. So what they do is it's micro JVMs, and they create a snapshot from the Lambda when it's running, and then they restart it from there, right? That's the main idea. And they implemented that in Corretto, and Amazon can do whatever they like because they own the cloud, that means the hardware, and they own the distribution, so they can do whatever they would like to do, right? So other distributions can't really do that because they have to just give it out for free for everyone, and then it's not all the time compliant to the TCK. Because the Snapstart stuff I don't know if it is TCK compliant. It hasn't, right? It's not really needed because they run it on their own infrastructure. Nobody runs Corretto on this desktop usually. Then there's Alibaba Dragonwell. It's another really huge distribution, and this is from China for Alibaba Cloud, which is more or less AWS just in China. And they have their own distribution, and they have 2 different versions, standard and extended edition, and they have something called JVM. The idea is, when you start up your application, the compiler, and first the interpreter, then the compiler start compiling and optimizing code. The idea is to store all this information, and the next time you start up, just tell the compiler what to do instead of going through all this stuff, right? The interesting part is this is the thing why it breaks the TCK, and what they used is the stuff that we developed years back before we switched to our own compiler, because we figured out you can't do that on the C2 compiler. And so what they do, and yeah, they break TCK with this. And it's experimental, so it doesn't really work reliable most of the times. Hello? They have something like Elastic Heap that they can give back memory to the operating system if it's needed. This is stuff that they implemented for better usage on the Alibaba Cloud. And they have Wisp too, which is stackful symmetric coroutine at JVM level. So they have, you see, they have some features in there, which is mainly things that they find useful for their own cloud stuff. And this is also for Corretto, right? So this is how it works. So people can add features to the distribution without breaking the TCK most of the times. And then you can have specific features that might be useful for you, like snap start in AWS Lambdas, right? It's a useful thing. Tencent Kona, yeah, this is, nobody knows Tencent, I guess. It's a huge company from Asia, and they're specialized on ARM, so they make lots of embedded stuff, and they have Kona Fibers. And Kona Fibers is something like Loom, but it's faster than Loom, and they prove that on their website. They have benchmarks, and they have it already in JDK 11 and 8. So this is there for 2 years nearly. So it's interesting, if you are interested in trying Loom stuff on 8 and 11, you can try Kona, right? And for 8, it has TCK. And there's ZGC for ARM. They also implemented that because they're really keen on all the ARM stuff. And for them, horseless garbage collection really makes sense. So this is stuff that they implemented. Then there's Bellsoft. Does someone use Bellsoft here? Who's using Spring Boot? Yeah, this is the default JDK that comes for Spring Boot. Liberica, and it has the ability to use JavaFX. So they bundle it if you like. You can get JavaFX bundled with the distribution, like it was in JDK 8 with Oracle. So because JavaFX was never really part of the JDK, it came just bundled with it. Okay. Then there's Bellsoft Liberica NIC. This is the native image kit. This is the Graal VM distribution. And that's the only Graal VM distribution that comes also bundled with JavaFX only for desktop. So you can create native desktop applications using Liberica NIC. I never used that, but they promised me that works. So yeah, I have to try it. Because there's another one that can do it, and that is, if it works, yeah, native desktop apps, come on, Gluon Graal VM. And Gluon, they do stuff where they bundle JavaFX always. So this is part of their Graal VM distribution. And you can create native desktop apps and, come on, Android apps and also iOS apps if it comes. So I have some iOS apps on my phone if you are interested in how it looks like, because people sometimes just trust it and say, I can't believe that Java is running on an iPhone or an Android phone. It works and it's fast. It's no problem to do that. It's not, I wouldn't use that always, but for some stuff it makes sense. So then you have to use Gluon Graal VM. And then, oh, come on. There's Oracle Graal VM. Yeah, I mentioned that already. They have Community and Enterprise Edition. This is a Polyglot VM. We have support for Java, JavaScript, Python, R, Ruby. And it has the Graal JIT compiler. That's what I already mentioned. So it's their implementation of C2 in Java. And they have the AOT compiler, which makes it possible to create these native images where you have very fast startup times. It's also quite useful if you would like to create command line tools, right? Because you have just one executable. And for this kind of stuff, it's really great. Because if you have Java, then you have always a folder with all the libraries and all that. This is just one executable file. That's quite nice. Go. IBM Samaru, I already mentioned that, and they have a lot of stuff in there. They have community and certified edition. We heard about certified stuff. It's based on OpenJ9, and that's the JVM implementation of IBM. So they took the JVM spec. There's a Java spec and a JVM spec, and they implemented the JVM on their own. And that means it can run all the same stuff that Oracle stuff or OpenJDK stuff can do, but it has a faster startup and low memory consumption, usually. Performance-wise, it depends. It can be faster, but I found that most of the times it's a little bit slower than OpenJDK. But that's not really a big problem here. They have other nice features. They have an AOT compiler, which is not the same as the GraalVM stuff, but this can compile dynamically code that is used often to improve startup time. And if it switches, they have instant on, and that's the same as crack, just from IBM. So it's checkpoint and restore on the JVM for faster startup, and they have a JIT server, which means you have you can think about, you have the server where you run the compiler, and then if you have services that run in the same environment, you just call the service where the server is running, and the code is compiled in the JIT server. The next time another service is calling the same code, it will directly get back the compiled code. So there's no need to compile it locally. It sounds strange, but it really works. So I know that because we have the same thing. Microsoft JDK, yeah, they implemented something. Yeah, they did, really, I promise. Oh, come on. No escape. So that's an experimental feature to decrease latency and improve throughput. And I'm not sure if this made it already in OpenJDK. I don't think so. At the moment, they just use it in Azure. If you use Microsoft JDK, they made some tests. And like I said, they also provide code to OpenJDK and did that there. Oh, yeah, okay, there's Zulu. This is one of our distributions. So we have, that's a free one. And it comes also bundled with JavaFX if you like. We have something inbuilt which is Azure vulnerability detection. Who's using a security scanner here? Just 2 people, really interesting. And I guess up to CI/CD. Or is someone running security scanners in production? Nice. Agent-based? Okay. So the reason why I asked that is usually security scanners stop at CI/CD. There are stuff that is running in production, but usually you use an agent that connects to the JVM and then talks to the JVM to get the information. And instead of doing that, we decided the JVM loads the stuff anyway, right? The JVM loads all the classes, and it knows where the classes are coming from. It knows the libraries. So we developed it directly in the JVM, and it talks to a forwarder that you can install in your infrastructure, and then this forwarder will talk to whatever web service that we have with all the information about vulnerabilities. How it works, and the good thing about that is you run your code in production, and then we can tell you what code was touched. And the difference why this is important is we can tell you if you use also vulnerable code. You might have a dependency on log4j, which is vulnerable. A CI/CD scanner says, oh, you have a vulnerable dependency here, you shouldn't use that. We can tell you if you use it, because if the JVM never loads the classes, then we know, okay, you have a vulnerable dependency, but you never touch the classes, so you're fine, right? So this you can only do if you really talk to the JVM itself. And in addition to that, yeah, we have code inventory. So because, like I said, the JVM knows all the classes that have been loaded, if you run that for some time, we can tell you, for example, after 6 months, the last 6 months, you never used that code in your code base. If you have a large code base, then this is usually a problem. And then it means you can maybe get rid of the code, right? Because you never touched it. And if you have old code bases, then that is often the case. And that really reduced time that you need for maintenance and security stuff. There's crack, coordinated restore checkpoint, that we also implemented in the JVM. And then we come to the last one, which is Azure Platform Prime. Oh, and we're running low on time. This is our Prime JVM that comes with all the bells and whistles that are available. We have our own JIT compiler, and that can run. Is someone running Cassandra here or Kafka, maybe? So if you just exchange the JVM, it can get performance increase up to 40 to 50%, and this just because of the compiler, and especially in Kafka and Cassandra we see that. So we have, like I said, the C4 garbage collection, which is pauseless, and it can handle heaps up to 21 terabyte. So we have one customer, I know that because we have a customer who has a heap of 21 terabyte. The first time I heard that, I was like, you mean disk space? No, I mean heap. I was a heap, okay. And that without pauses, so that's quite interesting. We have ready now. I told you about the J warm-up in Dragonwell. This is what we did in our compiler, which is ready now. It does exactly the same, but this works, and it doesn't break the TCK. So the compiler, all the compilations and de-optimizations it does, we save them. The next time you start it, it doesn't go through interpretation anymore. We directly, as soon as you touch a method and the compiler knows the method, then it knows how to compile it in the best way. So that gets you faster to the high-performance code. Cloud Native Optimizer, yeah, that's the same as the web compiler from IBM. And vulnerability detection, I told you. Code inventory, yes, it has really all of this stuff. And it will also get cracked. So, but this is not for free, you have to pay for this stuff. And this is really just for high performance. So if you have a, let's say, small or mid-sized company, you don't need really Prime usually, except you would like to use this cloud native compiler, optimizer or stuff. But usually this is for really high performance applications, high-speed trading, these companies, and bankings, insurance, they use this. Okay, takeaway from that session, hopefully, I mean, it was a little bit, still is, taking some time. So are all those builds of OpenJDK really different? Technically, no, they are not. They're not, yeah, not really, exactly. If it comes to service support and cost, then this is definitely a difference there, and you should take a look at that, because it makes a big difference. For example, if you are Oracle customer, do we have Oracle customers here in the room? Oracle JDK? No? Oh, that's good. They charge a lot for support, other companies doesn't. So choose wisely when selecting a JDK. And just for people who are interested, a colleague of mine wrote this book, OpenJDK Migration, and which is free. You can download the PDF. And yes, it's from Azure, and of course Azure is mentioned inside, but this is not the point. It will give you some hints what you have to take care about if you switch from one JDK to another. Let's say you switch from 7 to 8, or 8 to 11, or 8 to 17. What are the things you have to take care about? So you will find it in that PDF. It's not big, it's 70 pages. But we saw this helps a lot if you come to migration stuff. And with that, yeah, thank you, and thanks for your patience with the clicker. It wasn't my fault, but yeah, that's the way it is. If you have any questions, I will be here till 2, so you can reach me, and then I won't really take more time here.
Thank you, Gerrit. So, yeah, applause for Gerrit.